And and on top of it, you have a database. You make a database call. So imagine a scenario. I'm just now will come to know why cache is needed. So you have hit a URL, it came to your whatever load balancer, it came to your server, it went to the database, it got the item details, return it, render it, and serve to you. You are just hitting unnecessarily, you are checking the phones, this phone, that phone, are checking this dress, that dress, and you said, okay, I'm bored, I'm leaving it, and that's it. You made so many unnecessarily calls. You made DB calls, this. What they want to prevent this from happening because database resource is pretty expensive. They want to use it only for the transactional database. If you are really interested in buying and you want to do really shopping, then only they will let you hit the database. And how do? They most of the time they serve the data from the nothing but from the cache. They don't send you the real data from the database. Most of the time they send the data from cache. Only when you go to the checkout page, actual transactional page, they get the data from the database. Otherwise, everything is cached. In fact, the entire page is cached. Whatever the page you see on the item page, when you click on suppose a phone, all the data has been flattened out in a particular big fat JSON. It could be like thousands of JSONs all are merged together and put it back into the cache. When you click on that, it will simply get the dump of the entire JSON, render it, and put it in a second, right? So why do they do it? There are two reasons. There are two primary reasons. One, of course, they want to save the database cost. Second is they don't want to call so many API to gather the information. Just imagine when you click on a particular phone that you want to see this phone's data, just remember or recall the details what you see on that page. You see review details, you see the availability details, when it will be available, you see the product description, video, feedback, below you see a lot of other details, specifications, how to use it, what not to use, all these things you see on the single page. Imagine if you need to hit the databases, there will be more than 20, 30 or 50 or maybe 100 microservices will be kept in action that, hey, get me the pricing, hey, get me the order, hey, get me this, get me the feedback, get me the overall rating, get me this review, get me this videos, right? So many things will be there. And will you really think that you will be able to make so many calls, so many merging of the data and then providing that at in real time? That is a daunting task. And that also for what? Just for a window shopper, right? So just imagine these kind of scenario, how to tackle it. How can you tackle it better way? So the way you do is you basically, whenever a new product gets launched, during the setup process itself, you compute everything. Make a JSON, make a flat JSON, make a flat XML, make a flat protobuf, make a flat of data, whatever you do, you push it as flat as possible into the different cache. And when something comes with the product ID, with the machine ID, with the phone ID, whatever you want, you just get that, dump into the UI. Whenever there is a change happens, now the question is how to happen change. Whenever the change happens, again, you recompute everything in the backend because the product description changes and all these things are in e-commerce is a little rare because, it will not change that much, right? So in those cases, you can basically, what you do is that you again trigger update, you again make a flatten, just remove the older one, dump it with the new one. Don't do incremental updates, just delete the older one, put it the new one, whatever you have computed. So that is why you manage. And the cache is, this is one of the example, right? There are various other examples where you think that, there are a lot of reads. It is a read heavy application. You always use cache. Okay. So any question in why we should be using the cache? If you need to justify it, why do we need to use the cache? But it brings different challenges. And see, the thumb rule of the second thumb rule, the first thumb rule was what I had given you in the first session was, there's no perfect design. There's nothing like a perfect design. Okay. Google can't say their search engine has been designed perfectly. They keep doing the improvements. Google Maps also, if you have heard that, I'm not sure I have talked about this in previous session or not. There was one person who created a fake traffic in US. What he did is He took out his car, he took 20, 30 phones, he switched on the Google map, put into his car trunk. And what he used to do is he used to just, started on the road and he used to stop for 5 minutes. And then he used to just move a little bit. And then again, he used to stop for 8 minutes. Then he used to move for further 2 minutes. And within 2, 3 minutes, Google Map started showing there is a huge traffic on that road, on that stretch. Okay. So that is a bug. That is not a perfect design science, right? Because they hadn't considered that, okay, how come there are 20 phones within a meter or within a 10 feet of each other, right? There has to be a little distance because there are multiple cars. The 20 cars cannot fit it in within a feet or so. So that was one of the issue. That was one of the bug, correct? So if the Google map would have been the perfect, and you might have already faced a lot of issues while driving down, it might be have taken you to the very narrow roads, even though there was some much broader road was there. It might be you ended up at a dead end where there is no road and it is still showing you the roads. So there are bugs. Google search also there are a lot of bugs. No applications, no services is ever perfect because design cannot be perfect. There will be always edge cases. There will always be shortcomings, shortfalls, and they keep evolving. A product is not made in a day. It takes a longer time. So that is the first thumb rule. Second thumb rule, which I was talking about, is whenever you bring any new machine, new application, new tool, new technology, new set of tools, it brings their baggage. Okay. So bring the baggage means you cannot simply tell, hey, you come, you don't bring these things with you. No, they will come with the baggage, right? And the cache also comes with the baggage that we'll talk about, right? Let's learn about what are the types of caches we have, and then we'll know about that, right? So any question before that? I'll dive into the caching this one.
Divakar, while using cache, do we always have to ensure that the cache is in sync with the original data source, or this is a call that we have taken based on the we have to take based on the usage? So,
it is based on usage, and we will talk about the different use cases. In what all scenario you'll be using in what way. So whether it should be sync with the database or not, whether you want by default sync or you want an incremental sync or some periodic sync or on-demand sync. So there are different strategy people uses. Okay, those strategies is what I'm going to talk about now. So those strategies are named as, if you have read about that, write through, then there will be write back, write through, write back, and there is one more. We'll talk about that. Okay, so there is a read through, there is a write through, and there is a write back. There are three types of ways through which you can use the cache. Okay, and then there is a different invalidation methods. How, when you will invalidate, because your cache has to invalidate the way I told you, right? So you have dumped the JSON into the cache for the entire page. Now the product pricing has changed. You have to change that, right? You have to invalidate that cache, whether you want a periodic invalidation, where you want a on-demand invalidation. How do you want to do it, right? So those invalidation policies. So these are the policies and these are the behaviors in which you. So you will get your answer what you are asking, right? So you will get the answer now.
Okay.
Okay. So we now know, right? Why do we need cache? So we know just to avoid the DB call, just to serve the data in much faster way. So there is one reason is that you can avoid DB calls. So DB calls are expensive. It is more for a transactional data, more for data integrity. People use it. So you try to avoid as much as you can. The computation, the on demand, or you can say the real time, are avoided, right? So which means it becomes a low latency, right? So this is what it is used for. And you avoid the DB calls, you put less pressure, less stress on not only DB calls, even for your services also, right? You You can save your services. Services will make a DB call, right? So you are basically protecting your critical resources. The computations you avoid because you put the flat data as possible. Mainly, the cache uses key value approach. You put a key, you get the entire flat JSON. You put a product ID, you get the flat JSON. And then you have the very low latency because you are not computing on demand, not in real time, and that is what you get the benefit. We'll talk about the other issues later, what baggage it brings in, right? So there are various types of caches are there in the market. Couch-based DB, the famous one is the Redis server. You might have heard about it. You can read more about it if you want. I'll share some documents about the Redis, how it works, how do they design that, why it is used for. There are a lot of other things are there in that. That is beyond the scope of this training. I just want to highlight more on the importance of usage of cache so that you can bring it this point in the interview, right? So our discussion will be more around those concepts, right? So one, definitely, we use it for what kind of data, right? So we use it for database caching. So whatever in the database, and this it's a little database caching. So whatever is in the database, we cache it and then we serve the data from there. Then there are user session. This is also very widely used. It's widely used because the session is something which, once user logs in, you create the session object, you put all the RBAC roles, definitions, this, that, features they can access, dump into the JSON. As user will keep on browsing, you don't have to go check the database, roles, access every time, every page, every link. You just hit the user sessions cache data and then just get that as fast as possible. Then a lot of things are there, like you can do a in-memory lookup. You don't want to go to the database, you want to have a small footprint of something, you can put either in-memory cache or something like that. Okay, so this is where I don't think the 4 point will be there, but yeah, I mean more like a flat data, you can dump it if you really want to avoid the decoupling of those things. But these are the primary 3 types of data we store into the cache. Okay, now the question is, what type of scenario you can use in the cache? Then we will talk about the invalidation. So the first one is, we call it as, no need to remember these names. I sometimes forget. No need to remember the names, but remember the concepts, what are ways you can use the caching, right? And you might be already aware. So one is called the read through. What it means? It means that the data is first written into the cache, and then with the same transaction, with the same API, it also gets written to the database as well. Okay, so so just think about this one, right? So you have a client or an app. The request came to create a user. Now what you did is you first written this into the cache, and then at the same time you have written into the DB. Okay, and then once these two are done, you respond that 201, okay, it is created. If any of this fails, you return 500 or whatever, right? You basically make it in a single transaction. This happens in a single transaction. That okay, both should be written. So first it will return to cache, and then it will also be written to the DB. Now this is called the read through. That means, and now whenever somebody hits, if they hit the database, they'll get the data. If they hit the cache, they will get the same data, right? What it means, it provides the strong consistency. Right? It is highly consistent because both the data are in sync, they're not out of sync. And if anybody makes a call to this one, what is the problem with this? The problem is the latency. Now the latency in terms of the write. So your write will be little slower because you first need to write to the cache, then you get the response of the cache, then you go and write to the DB, then get the response from the DB, and then you return to the app user. So if you are looking for, just give me a second. There's some noise coming. I need to lock the door. Just give me a second. On weekends, a lot of kids, so I can't avoid that much. So what happens is when you do a read, sorry, so there are two things you do, right? So first you create the data and then you do the read data. Suppose you want to. So when you create, your creation will be slower, and creation will have a stronger dependency on both. If either of these fails, your create will stop working, and that means you are creating much more complexer. Like, if you have two systems to be data to be written, both has to be highly available. If any of this goes down, your all the create will start failing, because it has to write in both the places. If any of this fails, your write will start failing. So it is not highly write optimized, but it is highly read optimized plus strong consistency, which means if you do, once the data is written, whether you hit cache or whether you hit DB, it will always be in the sync. That is one thing. Second, when you do an update also, it will update into the cache, it will update into the DB. So whenever you look for update, both the updates will always be available in the cache and the DB. So it will always be in the sync. That is guaranteed. So if you really want that kind of strong consistency in terms of having the data across cache and DB, this is the logic you will have to use, but it comes with a cost in terms of writing the data, not in terms of reading. You're reading, that is why it is called the read through. So it will have a pretty good experience in terms of read, but it will have little challenges in terms of a create, because you're creating a strong dependency and also the latency. So latency plus the dependency challenges will be there for you. You got it, right?